When people hear that a single machine can train massive AI models faster than entire buildings filled with GPUs, the reaction is usually disbelief. It sounds impossible. After all, modern AI has been built on the idea that more machines mean more power, more chips, more servers, more clusters. But what if speed isn't about adding more pieces? What if it's about removing distance? This is the simple idea behind why Cerebras trains AI models faster than traditional GPU clusters. And it starts by rethinking how intelligence itself should move. Training modern AI models is no longer about raw calculation alone. It's about coordination. Billions of parameters must constantly update and stay synchronized. In GPU clusters, this work is spread across thousands of chips. Each chip handles a piece of the model, and they must talk to each other continuously to stay aligned. That communication happens through cables, switches, and networks. And every time information travels, it costs time and energy. As models grow larger, the system spends less time learning and more time waiting for updates, waiting for synchronization, waiting for data to arrive. The smarter AI becomes, the more painful this waiting gets. GPU clusters are powerful, but they are physically fragmented. Intelligence is broken into pieces and scattered across machines. Training becomes a constant conversation between distant parts. Imagine trying to write a book with thousands of co-authors, each in a different city, constantly emailing edits back and forth. Even if everyone is brilliant, progress slows. Not because of thinking, but because of communication. This is the bottleneck Cerebras was designed to remove. Instead of connecting thousands of small chips, Cerebras places everything on one massive chip, an entire silicon wafer turned into a single processor. The whole AI model lives inside one physical space. There are no long-distance conversations, no cables to cross, no network delays to manage. Data moves directly across silicon at incredible speed. In simple terms, Cerebras doesn't make computation faster. It makes communication almost disappear. AI training is a rhythm. Predict, adjust, repeat. The smoother that rhythm, the faster learning happens. On GPU clusters, that rhythm is constantly interrupted by delays. On Cerebras, it flows continuously. Every part of the model can update instantly because it's all right there. This allows larger models to train without falling apart under coordination overhead. The system behaves less like a committee and more like a single mind. In GPU clusters, a surprising amount of energy is spent just keeping the system synchronized. Cerebras removes much of that overhead. Less time managing infrastructure means more time actually training the model. This doesn't just improve speed, it improves efficiency. Experiments finish sooner. Iterations happen faster. Researchers can try ideas that would have been too slow or expensive before. Time becomes an advantage again. Training faster isn't just about convenience, it changes what's possible. When training takes weeks or months, experimentation slows. When it takes days, creativity accelerates. Cerebras enables larger models, deeper experiments, and more ambitious research without the logistical burden of massive GPU clusters. For certain workloads, this changes the entire pace of innovation. Cerebras isn't replacing GPUs everywhere. GPU clusters remain flexible, scalable, and ideal for many tasks. They are excellent general-purpose systems. But when models become extremely large and tightly connected, unity beats distribution. That's where Cerebras shines. This isn't about winning. It's about choosing the right tool for the right problem. Cerebras trains AI models faster not by adding more machines, but by removing the distance between them. By turning an entire wafer into one unified processor, it eliminates the hidden delays that slow modern AI training. The lesson is simple but powerful. Sometimes the fastest way forward isn't more power, it's less separation, less